All right, so today we're going to talk about a brand new operation that we can do with functions. So, given two functions f and g, you can create functions by substituting one function into the other in place of x. So rather than plugging in a number like 1 or 2, or maybe you get crazy and you plug in 1/2, we're going to plug in a whole function. And so this is called composing or composition, and it looks like this: f of g of x, or f of g of x, just like those other operations we talked about, where, like, for example, we could write addition as f plus g of x, or we could write it as f of x plus g of x. There's two ways to write composition as well, and we will use them interchangeably, so we'll be familiar with both. Again, remember, this is about notation, right? We're plugging one function into the other. Something to notice here, right, is this is an open circle used here. It's not a dot that denotes multiplication. And we say f of g of x. I know it's kind of a mouthful. F of g of x. So, given two functions here, we're going to go through and look at some of this. First, we're going to start off by evaluating for a specific value of x, and then we'll see what happens if we leave everything in terms of x. So if you follow along before, you know I'm big into color coding, so we're going to, let's make f of x minus 4, and let's make, or f of x pink, f of x is x minus 4, and let's make g of x green. Alright, so this first one is f of g of 1, and I would totally encourage you to keep saying it out loud to get that practice. Alright, so what this means is taking my function inside my function, but whatever I get when I evaluate my function g, x is 1. Alright, so that means I need to figure out what's going on in my function g at 1. So I've got f of, and then I just plug it in right here in the notation so I don't lose anything. So in this g of x, it looks like 1 goes in place of x, 1 plus 2. Alright, so that means that g at 1 is going to be 3. So that means function f, we are plugging in 3. Alright, so what is my function f? My function f was x minus 4. Plugging in 3, so I've got 3 minus 4, and that's negative 1. Alright, look at that, guys. You just did your first composition. Alright, now we're going to see what this looks like in the opposite direction. So we're in g of f of 4. So g of, this is like f of 4, so we practice with both sets of notation. So before I can plug anything into my function, I need to know the value of my function f when x is equal to 4. So I'll plug in 4 here. That actually end up getting out 0. So what we're going to be doing is evaluating g when x is 0. I'm going to end up with g of x was x plus 2. So we're going to put 0 plus 2, which is 2. Well, what happens if we are evaluating our function? So what if we're taking f of x and g of x and we're keeping them in terms of x? So here we've got f of g of x. So this is going to look like function f. And in place of x in my function, I'm going to put my rule for g of x. So we have to be thinking, what is my function rule for g of x? The whole function rule is x plus 2. So everywhere in my function f, there used to be an x. I'm going to put a big old set of parentheses. And the rest is minus 4. So it used to be x minus 4. Now, in place of x, we're going to put x plus 2. Then we just combine all our terms here. We've got 2 minus 4, and so we'll end up with x minus 2. Okay. Not so bad. Next. We're going to do the opposite. So our function g, and into our function g goes our function f. So, what is my function f again? It was x plus 2. So, in my function g, which used to be x plus 2, I'm going to put x minus 4. But I like terms. And again, I'm going to end up with x minus 2. Now, it doesn't always happen that when you compose functions, you get the same thing. It has to do with the fact that our functions here were pretty simple in that they were both linear functions that had a slope of 1 and an x, just an x-intercept that we had to deal with. So back here, you're going to see that we have multiple functions. And so this is how I like to work with function operations with my students. So let's get lots to choose from. Let's get everything colored. So f of x, wow! This beautiful quadratic trinomial. G of x is 3. H of x is so again, you're going to see a mixture of the two different ways that we can notate each of these operations. You're going to see that we have a mixture of the regular operations that we've learned previously, like adding, subtracting, multiplying, dividing. I did throw composition in here, obviously, and then some of them we're evaluating for a specific value of x, and some of them we are not. Alright, so let's get cracking. We've got f of g at 1, so f of x here. F of x here looks like inside f of x. I plug in b. Alright, now we need to know what is the value of my function g at 1. So this is going to look like, well, g of x is x minus 3, so this will be 1 minus 3, or negative 2. So it'll be f at negative 2. So in my function f, because it's a quadratic trinomial, there's 2 spots where I'm going to plug in my inputs. Especially if I'm plugging this into my calculator, I don't want to mess up with those negatives. If you plug in negative 2 squared without a parentheses, your calculator is going to square the 2 and then negate it afterwards. And so it's not going to recognize that it's negative 2, the whole quantity being squared. This is going to end up being 4 minus 4 minus another 4 So we'll end up with negative 4 as our answer, because 2 will go up here. 3. So H, 3, well, this is going to become 3 squared, which is 9, by plus 2 times 3, which is 6, minus 3, 2, minus 11, division. So we're going to have to add 4 4, 4, 3, those two functions. So this will look like we're adding those. End up with, start combining terms. We have x squared up front, x plus 2x is 3x. H of x. So this will be x plus 1, making sure we're using parentheses so that we can distribute that negative. So this is going to be x minus 1. So those x's will 0 out. We'll end up minus 4. A couple more, guys. You can do it. G of x was that triennial x squared was x. Double distribute minus 3x Here, each. Eight was. So I'm going to put whole attention. 3. Last but not least, f of h of x. This one's a fun one because it has lots of distributing. F and x. F is that quadratic term, x squared term, and then we have minus 4. So everywhere in those parentheses, we're going to bring back FOIL, or if you see that this is plus 1, that is a perfect square trinomial, so it's equal to terms to combine, x squared, and we're going to have 1 plus 2, that's 3, take away 4, minus 1. Correct. Mastered composing functions, a whole new operation.